Analogies in Physics, Part 7 of 8. Space and Time Classification Diagrams. A modification of purely time diagrams. To construct a time-space diagram, you must make a slight modification of the purely temporal schema. This change is seen by comparing the particle mechanics diagram to the left with the right one. The vertical lines of the left becomes inclined line on the right. It is a view in perspective, or if you want, in astrometry, of the diagram of particle mechanics. This will help us to build a three-dimensional diagram for a time-dependent field, like a house seen in astrometry, as shown in subsequent slides. How to add the time to a classification diagram? To get a three-dimensional diagram starting from a special diagram, you should move the diagram to the right and to the top. In this way, the layout of the different boxes is similar to a three-dimensional four-story building with the front is the first part, and a back. Well, these are the time arrows that connects the instants with the intervals. On the left, these are the configuration variables. On the right, you have always times arrows that connect instants with intervals, both on the left and on the right. Hence, we have this typical structure with the arrow coming from back to front on the left and from front to back on the right. Here you have the space and time elements. The arrow on the left side are time arrows, go from back to the front and connected instants with interval. The arrows on the right side go from the front to the back, and they also connect the instant with the intervals. The structure of the diagram with time. Mechanical theories. This is a typical diagram. These are the primal time elements typical of mechanical theories. And here you have the dual time elements, typical of mechanical theory, once more. For example, here you have the position vector, here you have the velocity, you have momentum, and here force. These are the possible relations between the variables, and eventually there are also irreversible links that connects a box, a physical variable that belongs to a time element with another which belongs to the dual time elements. Hence, T bar here and T tilde here. T bar here and T tilde here. This will be explained later. In the field theories, the matter change. Here we have the dual time elements, and here you have the primal time elements. Once more, you have possible relations and also irreversible relations that connect T tilde with the T bar. This means that the physical variable contained here change sign with reversal of motion. On the contrary, the physical variable inside here does not change sign for inversion of motion. Irreversible and reversible links. The irreversible link between two variables arises when one of the two variables changes the sign by reversal of motion, while the other does not change sign. In the diagram, this fact is reflected in the fact that the constitutive equation joining the two variables is inclined from the front left to the back right and will be denoted by a dotted line. This means that the diagram also shows the distinction between reversible and irreversible relationship. This is very important because it shows that all horizontal relationship linking a left variable to the right that lies both on the front or to the back are reversible. In fact, they connect variables that have the same behavior under reversal of motion. For example, it connects an instant with internal orientation, with an interval with external orientation, or vice versa. The structure of the diagram with time. For mechanical theories, you have the primal time element on the left and the dual time elements on the right. Remember the diagram of particle mechanics. Hence you have the particle mechanics, mechanics of system, analytical mechanics, mechanics of deformable system, fluid mechanics. But there are also field theories, two kinds of diagram for the two kinds of theories. In these cases you have the dual element on the left and the primal elements on the right. Examples are all theories in which there is no force as source. So is electromagnetism that is generated by charge and electric currents. The thermal conduction whose source are heat generators. The theory of gravitation whose source is the mass. In the following, we show three examples of time variable field diagrams. Case of thermal conduction in the differential formulation, the transverse vibration of strings, differential formulation also, and electromagnetism in differential formulation. Here you have the thermal conduction. The physical variable, it is a field theory, are the temperature that is associated with the points, and since it does not change sign under reversal of motion, this temperature is associated with the dual time intervals. So is a gradient of the temperature. The temperature gradient does not change sign for reversal of motion. Here you have associated with volumes and instant the internal energy. And the internal energy is linked to U0, a conventional value, plus C times T. This is capacity, the capacity. On the other hand, you have the internal energy source, sigma. And also you have the balance equation, the equation of conservation. The time derivatives of U plus the divergence of Q. But Q, what is? Q is heat current density. Hence, you have a phenomenological law, the law of Fourier, that links the heat current density to the temperature gradient. And this is an irreversible link. For this reason, we have drawn the line here in pieces instead of be continuous. And look that this relation is reversible because Q change sign, the heat current density change sign under reversal of motion. On the contrary, the gradient of the temperature, like the temperature itself, does not change sign. Now, let's consider the transverse vibration of a string in differential formulation. Consider a string like that of all string of musical instrument, violin, guitar, harp, piano, and so on, subjected to transverse vibration. The string is initially in the straight horizontal position and is subjected to a certain traction, Tx. For simplicity, we refer to the strings of an horizontal piano. Experience shows us strings vertically stressed in a way, pinched, moved with fingers, like in the guitar, beaten by hamstring like in the piano, undergoes sweeping vertical movement, while the horizontal movement are almost null. Under these two assumptions, the time function variable can be considered. The first is a vertical displacement. The second is a vertical component of the traction. We will consider that the force that moves the wire agitates vertically, and, as said before, during the movement, the horizontal projection of the traction. The statement that the horizontal component Tx of the traction undergoes so small variations that it can be ignored, and that the transverse waves and that the traction is always measured along the tangent to the string, indicate that Ty, the ratio between Ty and Tx, called this ratio, is equal to the angle alpha, to the angle alpha that is small, but exactly to the tangent of the angle alpha. The transverse vibration of a string. Here you have the diagram. Y, the displacement, and Qy, the vertical component of the force that excites the motion, a force applied vertically. Here you have Vy, that is a velocity in the direction vertical, and Py, that is a momentum density. Momentum density, rho is a density of mass times velocity, the momentum density that is also in the direction, vertical direction. The angle alpha is formed by the tangent is equal to the first derivative of y. And Ty is a component of the traction here in vertical direction, Ty. And as we have said before, the ratio between Ty and Tx is the angle alpha. Ty divided by Tx is the tangent of this angle, and for small displacement that we are considering is equal to alpha. Here you have the precision of the symbols. I can give a look because they are described. Electromagnetism, differential formulation. This is more complex to be described, and we refer to the book of the author. Every case you have the electrostatics here, and you have magnetostatics on the back. Here the typical error, that, and here the Ohm's law that is reversible and is represented by a dashed line. Of course, the different variables are well known and can be studied apart if the student has not already the knowledge of electromagnetism. Well, we remark that in the differential formulation of physics, we make use of space and time coordinates. Hence, we have scalar or vector or tensor-valued functions. A function may be of x, xy, xyz, time, and so on. In contrast, we emphasize the association of physical variables with space and time elements. Since there are 4 space-time elements and each of them have 2 orientations, we have 8 oriented space elements. Since there are 2 time elements and each of them may have 2 orientations, we have 4 oriented time elements. Well, since every physical variable has an association both with the space element and with the time element, we have 8 times 4, 32 space elements. Hence, every physical variable belongs to one of these 32 classes, associated a function associated with a primal instant, a primal point, or associated with a dual time interval and the primal time interval and the primal volume, a volume endowed with inner orientation, and so on. This is a pictorial view of the diagram. You have the configuration variable on the left, the source variable on the right. On the left you have the field equations, and also field equations are here, respectively configuration and source equation. The bridge that links the left with the right side, or both with the right side with the left, are the constitutive equation. And here you can speak of a phenomenological river because between the two there is a phenomenology, and these equations are constitutive equations, as we shall explain in next presentation. This is a pictorial view of the structure of physical theories. We conclude with a remark about John Kepler, the discovery of the Keplerian law. He was a man who adored harmony and order, and everything he discovered was associated with its perception of God. And the remaining can be read. Okay, this is the end of part 7